In this video, I'm going to review variables and expressions very briefly for you. All right. I'm going to talk a little about what the variables and expression mean, how to combine terms, what distribution is, what FOIL means, what a polynomial is, as well as related terms like coefficients. And then I'll give you some examples of all of that. All right. So a lot of times you will be thinking of a puzzle in your head, and there might be a quantity that you do not know what it is, but you still know something about that mystery quantity. For example, if I double a quantity, I get 10. All right, and let's say you are struggling to figure out what that mystery quantity is that is 10 when you double it. Okay, now I just described a puzzle to you in words. All right, and in your mind you go, okay, I have a mystery quantity, I double it, and I have 10. Now that whenever the problems get more complicated, then it can be hard to hold it in your head and communicate in English. Okay, so mathematicians have developed a very compact notation to describe math puzzles regarding quantities like that. Okay, so you represent the unknown. So variables, these are letters that represent, or not, they don't necessarily have to be letters, and they could be letters with subscripts. And so let me just say symbols to be more generic. Symbols that represent unknown values. Okay, and so for example, you could call a unknown value the letter X is traditionally a common one, but there's no reason you couldn't use A or B or C or Z. Okay, and if you really wanted to freak people out, there's no reason you couldn't use happy face or star. Okay, you get the idea. So it's just a symbol, a placeholder until you figure out what the value is. All right, and an expression is nothing more than a representation of one or more operations that lead to quantities. All right, that's a lot of words. Probably an example would be instructive. So I talked about doubling a variable and getting 10, right? So that's an operation that leads to a quantity, the quantity being 10. So the doubling some mystery value, let's call it x, and that's equal to 10. Okay, so in that blue the x is the variable, 2x is the expression. Okay, when I have an equal sign, I'm actually creating an equation. Okay, the 10 is also an expression, and so I'm saying that the expression 2x is equal to the expression 10. Let me give you an example of an expression without an equal sign. So I could say 3x plus 7, or y divided by 2, or even 17 plus 4, or just the number 25. All right, so an expression could be a number. It could be numbers added, subtracted, multiplied, divided together. It can also involve variables. Okay, all of that stuff is expressions. Okay, and so the expressions provide a nice compact way to get all those ideas in English out of our head into something we could look at and work with. All right, so let me now talk about the mechanics of simplifying working with expressions. All right, so let's say we had 2x plus 4x plus 5x squared. Okay, now, and let's say we wanted to kind of clean it up, make it look a little bit simpler. So 2x and 4x, if I have 2 apples and 4 apples and I add them together, I don't think anybody would disagree that that gives us 6 apples. Alright, let me just do that, and let me not touch the 5x squared for right now. Okay, now does adding, now x squared is an entirely different animal than x. So please don't do this. Don't say that 6 apples plus 5 bananas is equal to 11 apples or 11 grapefruits, or okay, it's not equal to 11x, it's not equal to 11x squared. None of these, you can't combine those two. Okay, you may have heard the phrase that you can't add apples and oranges. You can only add things or subtract if they are the same type of blob. Okay, same expression, same type of expression. Alright, so let's get that clear. Alright, now another concept related to expressions is dealing with parentheses. Alright, if you have 5 times a sum in parentheses like this, you can work it out, and well, first of all, this is 5 times 7 because a parenthesis gives us 7. Okay, now it'll sometimes be useful, rather than simplifying the parenthesis first, it'll sometimes be useful to simply take the number in front and multiply it by each guy inside the parenthesis. Okay, and you will see that this will always give the same answer. Okay, so distribution has to do with getting rid of parentheses by multiplying everything inside the parenthesis by whatever's on the outside. Alright, let me give a slightly more complicated example that uses variables. Let's say I had 4x squared y times a plus b. Alright, the same idea applies. I simply take the blob on the outside and I multiply it by each guy on the inside. So this would be 4x squared ya plus 4x squared yb. What if I had a subtraction instead of a addition? So let's say now, how about 10y cubed times d minus c. Alright, this time you still multiply like we did before, but this time you're going to subtract the product. So 10y cubed d minus 10y cubed c. Alright, so that's all well and good. What about if you have 2 parentheses, for crying out loud? Now what do we do? Alright, so if you're good with this, let's talk about that. So what if I had something like 5 plus 1 times 2 plus 3? Alright, now we happen to know that that's the same as 6 multiplied by 6, 6 multiplied by 5, and so the answer has to be 30, and nobody's going to convince us otherwise. Okay, now you can also do this. You just like before when we had a single term, we had a number or an expression that didn't involve addition on the outside. You can think of it as 2 versions of those. So you can think of it as the 5 in front of the second parenthesis plus the 1 in front of the second parenthesis. Okay, and we know how to do each of those products, right? So let's go ahead and distribute 5 times 2 plus 5 times 3, and then the second one is 1 times 2 plus 1 times 3. Let's work that out. 10 plus 15 plus 2 plus 3, and lo and behold, we get the same answer. Okay, so let that be your guide. You can have 3, 4, 5, 6 parentheses all multiplied together, and you can break it up into lots of simpler distributions. Okay, let me do an example with variables. X plus y times a plus b. I take the x and multiply that by the a plus b blob, And I take the y, multiply that by the a plus b blob, explode all that out, xa plus xb plus ya plus yb. Okay? This will always steer you right. Now, let me just tell you now a shortcut. You'll notice that it always took me 2 steps to do the double parentheses, right? Now, you could, if you like, you could memorize what I'm going to say next. It's sometimes referred to as FOIL, and this will help you to do it in 1 step. All right? Let's go back to x plus y times a plus b. And so whenever you hear people use say, oh, just do FOIL, okay, here's what they're getting at. Each letter in FOIL stands for a certain pair. F stands for firsts, the L stands for lasts, the O stands for outers, and the I stands for inners. Alright, now what does that have to do with the product of the parentheses, you ask? Okay, I'm going to use FOIL and you'll see that it's going to give the same answers we had before. Alright, what I mean by the firsts, I mean the first term of each parenthesis. Alright, so clearly that's the X and the A. Alright, so those get multiplied together. Alright, by the lasts, that mean, well, the lasts of every parenthesis. Okay, so those guys get multiplied together. Okay, and so what about the outers and the inners? So that one, the outers, those have to do with the extreme left and the extreme right. Okay, so these right here, these are the outers because they are on the edges of the whole shebang, right? The farthest to the left, farthest to the right. So those are the O's. Okay, so that gives us an XB. Okay, and then the inners are the guys that are not on the edges, on the extreme right and extreme left. So the Y and the A, these give us the I's. Okay, so plus YA. Alright, and so that is FOIL, and you'll see that that gives the same as we had before in 1 step. Alright, let's do some examples now of distribution, FOIL, and combining like terms. Okay, so let's say I wanted you to expand and simplify, if possible, the following. So here we go. What can you do with the following? Can you simplify this expression at all? All right. What about, can you expand and simplify this blob? And then lastly, can you expand and simplify the last one? All right, so you can pause the video now if you like, and I'll work it out shortly. All right, so for the first one, again, remember we can only combine like terms, so I'm going to add those that I've circled. That's going to give 5x squared, and then I'm going to combine those that I've underlined, and that's going to give 6x cubed. The second one, I'm going to multiply the outside by every guy on the inside, taking care to handle the minus correctly, and that's going to give me that. And then the last one, I'm going to do FOIL. All right, the firsts give me that, the lasts give me that, and I didn't do an example previously with a minus sign on the FOIL, but if you have one minus, then the product will be negative. If you have two minus, if they're, like, let's say I had -1 and -3, two negatives will give a positive product. Okay, and then in the middle you will have the inners will give an x, the outers will give a -3x. Okay, and you noticed previously that I put the lasts way far to the right. That's because often you will have that the inners and outers go in the middle, and they will often be of the same kind so that you can combine them. So for this one, you can combine the inner product and outer product, so you get minus 2x. All right. Now, often you will when you get really good at this, you'll do it in your head. I did it here in 2 steps, but if nobody was looking, if this was for my own purposes, I would have done it. I would have added the inner and outer products in my head. All right. And then let's talk about polynomials now. All right. Polynomials are expressions that do not have any exponents that are not natural numbers. That means 0, 1, 2, 3, 4, 5. So you can't have fractional exponents. You can't have negative exponents. Okay, so that's one criteria to join the club, is only simple natural number exponents. Okay, they also do not have variables in the denominators. All right, that would make it not be a polynomial. So let me give you some examples of polynomials, and let me give you some examples of expressions that are not polynomials. 4x plus 1. All right, there is no exponents, or you might say there's an explicit exponent of 1, so that's a natural number. I'm not dividing by variables, so that one works. 3xyz plus abc. It's okay to multiply by several variables. Again, I don't have any weird exponents and no division. Okay, and then for the next one, how about 4/7 x to the 8th y to the 5th z squared minus 1/2 a cubed b to the 4 c to the 9th. Yes, I do have a quotient. Okay, I have fractions, but notice that the fractions only have numbers in the denominator. Okay, so those get to join the club of polynomials as well. So those are all valid polynomials. Now, what about some things that are not polynomials? Okay, so 14b to the minus 2, that one doesn't get to join the club because of the negative exponent. Okay, 2x divided by y. That one, you have a variable downstairs, so that one doesn't get to join the club. All right. Square root of y. All right. This is the same as y to a fractional exponent, isn't it? All right. So that's why that doesn't get to join the club. Okay, so square roots, any kind of roots, don't get to join the polynomial club. All right, now a couple of other definitions. When we talk about the pieces of a polynomial that are added or subtracted together, each of those little blobs is called a term. So I'll circle the different terms. So the first one, 4x and 1, are 2 terms that are added together. In the second polynomial, those 2 circled terms are added together, and in the third one, these 2 circled terms are subtracted. They compose a difference. All right, so that's what a term is. Now, another definition is a coefficient. Okay, coefficients have to do with the numbers in polynomial, in terms of the numbers in the terms of polynomials are the coefficients. All right, so in the first polynomial, we have a 4 because that's coming along for the ride on the first term. All right, you could say that 1 is the coefficient, although usually it really comes into play. You're really talking about when there's variables involved, and you exclude the variables, and the numbers left over are the coefficients. Okay, For the second polynomial, the 3 is the coefficient. All right. For the ABC term, you might say there's an invisible 1. Okay, so the coefficient is a 1 if you really had to specify an exponent, a coefficient. And then on the third polynomial, the 4/7 is the coefficient, and then the 1/2 is the coefficient of that term. Okay, if you want to think of it as you're adding a negative 1/2 a cubed b4c9, then you would say that the coefficient is -1/2. Okay, but it's always the numbers. All right. So in case that wasn't clear, let me show what I meant on the last one. So you could rewrite. It would be equivalent to write the last polynomial this way: 4/7 times x to the 8 y5 z squared plus -1. You see what I'm getting at? So now I'm putting the negative into the second term. All right. If you did that, and only if you did that, now the coefficient is not just the positive 1/2, but it's the negative 1/2. Okay. And now let me move on. All right. So people talk about evaluating expressions. Okay. Evaluating expressions means replacing variables with values and simplifying to get a single number. So in other words, doing the work, so to speak. All right. So for example, if I had x plus 1 and I told you that, well, now I happen to know that x is 4. Okay, so I'm going to replace the x in that expression with 4. So 4 plus 1, simplify that, and I get 5. So if somebody was to ask you to evaluate x plus 1 with the value 4, then you would say, oh, okay, the evaluation gives 5. All right. You can have more than one variable. For example, 3ab plus 5a squared b cubed. All right, and let's evaluate that with a equal to 0 and b equal to 1. And so 3 times 0 multiplied by 1 plus 5 times 0 squared multiplied by 1 cubed, and that gives 0. All right, that's valid. That's all I'm going to say about evaluating expressions. Now, the other thing you need to know is I started this video by describing how somebody will give a problem. They'll first communicate it to you in English, and I talked about how variables and expressions provide this wonderful compact notation. Okay, you have to get very good at converting English into compact expressions using variables. All right, so I'll do a few examples of that. All right, so let me just, I guess, write out a few phrases. So doubling some amount and adding 4. Okay, what about also cutting some amount in half and removing 3? Okay, and what about, let's say, adding 2 amounts and then adding 10. Alright, so decoding these English phrases. So doubling some amount, and so first thing we need to do is decide on what letter we want to use for the unknown amount. And as I said, traditionally we use x and y, but you don't have to. Doubling some amount and adding 4. So doubling mystery value x and adding 4 would look like that. Cutting some amount in half and removing 3. Just for variety, I'll use a different letter. So let's take the letter y, the quantity represented by y, divided by half, and then minus 3 represents removing 3. Last one, adding two amounts, and then adding another 10. So this time we have two unknowns. So how about a plus b, and then adding 10 would be plus 10.